Today we are going to look at section 2.3. That is going to have us draw logical conclusions. So let's talk about the procedure for drawing logical conclusions. It's important to memorize theorems, definitions, and postulates. So for us, we've looked at a lot of different definitions of vocab words. In chapter 1, we were doing vocabulary pretty much every lesson. So we had, bisect, trisect, midpoints, congruent, all that kind of stuff. We've started talking about complementary, supplementary, perpendicular, all those different types of things. So it's important that we have all of these things memorized and ready to go. We're going to look for keywords and symbols in the given information. Okay, so they'll always give us some information that we're going to be able to use. So circling those keywords and vocab words and different symbols is going to be important. So then once we know what the keyword or symbol is, we go back to like step number 1, we think about all of those things that involve those keywords. We'll then decide between which theorem, definition, or postulate we're going to allow us to then draw our conclusion. And then we'll draw a conclusion, which will then give us a reason to justify the conclusion. So we want to make sure that we do not use the reverse of the correct reason. I'll definitely explain more of this when we start doing example problems, but how we word things is going to be crucial. We don't want to accidentally reverse what we're trying to say. All right, so let's take a look at this first example. So having a picture here is going to be important. We can go ahead and we can mark things up once we know what our vocab word is. So if we are given that the ray AB bisects the angle CAD, hopefully we're okay with understanding that our vocab word is bisect. So we have to think back to what does it mean to bisect? Well, to bisect means that we're going to divide into two congruent pieces. The fact that this particular problem is talking about an angle, well, that means that we should be naming two smaller congruent angles. So looking at this picture, notice that the angle itself has A in the middle, and so that's where the vertex is. And so if we're trying to figure out, well, what are the two smaller angles that have to have that vertex of A? Notice that that would be angle CAB, that would be this angle, and angle DAB, so this angle over here. So that's essentially what our conclusion is. If it's asking, or when it says that the ray AB bisects angle CAD, our conclusion is that the angle CAB is congruent to the angle DAB. Now, if you have the C and the B switched around in the first one, and same thing, the D and the B switched around, that's perfectly fine. But A had to be in the middle because that's the vertex. Our conclusion has to be that we have two smaller congruent angles. So now we're going to justify this reason by just talking out and explaining what it means to bisect. And our justifications are very broad. We're not going to be specifically naming angles with letters or anything like that. We're going to be talking about a broad statement. So this would be our justification. If a ray bisects an angle. So notice that the whole given talks about a ray bisecting an angle. That went first in our statement. We're just describing what was given. If a ray bisects an angle, then it divides the angle into two congruent angles. Well, notice that what we were concluding was that we had two congruent angles. So that's why anything that comes after the then is just broadly describing what our conclusion is. So if a ray bisects an angle, then it divides the angle into two congruent angles. So like I just stated, I want us to note the if part always matches with the given. It is a broad description of the given. The then, what comes after the then, matches the conclusion. So once again, it was a broad description of the conclusion. This is always going to be the case. Okay, if you reverse it, you did not do it correctly. So the given goes with the if, The then is the conclusion. All right, let's take a look at this next example. So we are given that the line AB, is perpendicular to the line BC. All right, so this symbol right here is the important symbol. Like I just read off, it means perpendicular. So we have to ask ourselves, what does it mean to be perpendicular? Hopefully, we're thinking that perpendicular forms right angles. So I need to look at my picture and I need to figure out, well, where would that right angle be located? Hopefully, we're okay with putting that symbol right there. So it turns out that in this picture, there is only one angle at that vertex of B. So we could just say angle B, or we could name it with 3 letters, but hopefully we're okay that because we were given perpendicular, our conclusion is that we have a right angle. So in this particular picture, we know that angle ABC, or you could have just said angle B, is a right angle. So that is my conclusion. And now I'm going to justify it with an if-then sentence. So remember, the if part is what was given. So since we were given that we have line AB perpendicular to the line BC, I'm going to broadly state that. So I would say if 2 lines are perpendicular, the then part is what we're concluding. Well, if we're concluding that we have a right angle, then we would say they form a right angle. So if 2 lines are perpendicular, then they form right angles. Okay, so the if part is what was given, the then part is what we are concluding. It's a broad statement, but our actual conclusion is a very specific statement based off of the diagram. All right, if we look at this next one, we are given that the angle WXZ, so I'm going to mark that in my picture, WXZ is right there. That is congruent to the angle of YXZ. That's this angle right here. And so I marked them the same because we are told that we have congruent angles. So if we have congruent angles, in this case, we have 2 small congruent angles. But notice both of those angles are formed at the same vertex. They're formed at vertex X. So notice that if we put those 2 angles together, it gives us this bigger angle of WXY. So we're actually going to kind of think in the reverse from that very first example that we did. In the first example, we were given that we were bisecting an angle. And then we concluded that we had 2 smaller congruent angles. Well, in this case, I'm starting with 2 smaller congruent angles. Obviously, they share the same vertex, which is why then we can conclude that the ray XZ bisects the angle WXY. So notice that the ray starts at the endpoint, which is the vertex of our angle. We use the word bisect because what we had were 2 smaller congruent angles. And since they shared the same vertex and they started off as 2 smaller pieces, that's because they were divided into 2. They were bisected. So our if-then sentence could state if an angle is divided into 2 congruent angles, because that's essentially what we were given. We had 2 congruent angles, but they were at the same vertex. So it was an angle divided into 2 congruent angles. Then the angle is bisected. The then part is what we are concluding. Because we used the word bisect in my conclusion, that's why I had to use the word bisect after the word then. So the if is what was given, the then is what is concluded. Here's another example. Say we are given that point E is the midpoint of the segment AC. So once again, we have to look at our given and we have to try to determine what is the vocab or the symbol. Hopefully we're okay with it being midpoint. So now we have to ask ourselves, well, what is a midpoint? So the formal definition is that it's a bisection point of a segment. Notice that in this particular problem, We're saying that it's the midpoint of the segment AC. So if this is the segment that I should be focusing on, if E is that bisection point, which means that it is the point that's in the middle, we have to ask ourselves, well, what can we conclude from that? Hopefully we're okay. If E is in the middle, it's creating two smaller congruent segments. Those would be the segments AE and EC. So my conclusion is that the segment AE is congruent to the segment EC. Now I want to justify this. Well, if an if-then sentence, the given started with a midpoint. So I know I need to use the word midpoint with the word in the if part of our sentence. The then part is what we're concluding. Well, we're concluding that we've created two smaller congruent segments. So here's our justification. If a point is the midpoint of a segment, then the point divides the segment into two congruent segments. Okay, so I don't want to just say that then I have two congruent segments. I need to talk about a segment being divided into two, because a midpoint, even if I'm given a midpoint, it doesn't necessarily mean that I can then just say two congruent segments, because like here, this is the segment, let's say that's AB, and let's say that this is the segment CD. If I say that they're congruent, it doesn't mean that that was because a midpoint made them congruent. I just had two congruent segments. So that's why with this particular problem, if I'm starting with the midpoint, I need to talk about how that one segment was divided into two congruent segments. All right, here's the next example. We are told that the angle DEF is complementary to the angle HEF. So hopefully we're okay with complementary being that key vocabulary word. And so if we're talking about complementary, well, remember the definition. Complementary means that we have two angles who add up to 90, or who's forming a right angle. So if we're talking about this little angle of DEF and this little angle of FEH. Now, notice I marked them different because I don't know that they're congruent. But together, they are forming this big angle of DEH. And because we're talking complementary, we're talking about then we really have a right angle. So my conclusion is that angle DEH is a right angle. So now to justify this, complementary was given, so the word complementary has to be in the first half of our sentence with the if. So if two angles are complementary, then they form a right angle. So notice that because I concluded a right angle, I need to state right angle in my justification. If you said angle DEH is 90 degrees, if that's your conclusion, that's a legit conclusion. But then you would have to say if two angles are complementary, then they form a 90-degree angle. So you just want to be consistent. If you state right angle in your conclusion, state right angle in your justification of that conclusion. If you said it's a 90-degree angle, well, then you'd have to say 90-degree angle in your justification. Okay, so this is us drawing logical conclusions.